Now we are moving on to problem solving. So this will be the first example. So the turning moment diagram for a petrol engine is drawn to the following skills. Turning moment, for the turning moment, 1 millimeter is equivalent to 5 Newton meter, and for crank angle, 1 millimeter is equivalent to 1 degree. So this is the first thing which you have to deal with, is to convert this to radians. Okay, so you can take 1 over 180 times pi. Now, the turning moment diagrams repeats itself at every half a revolution of the engine, and areas above and below the mean turning moment line, that means mean resisting top line, taken in order are 295, 685, 40, 340, 960, and 270 millimeters square above. So you start with above and then below. So this will be above, and this will be below, above, below, above, and below. So remember, above mean resisting top line we consider positive, and below we consider as negative. So the rotating parts are equivalent to a mass of 36 kg at a radius of gyration of 0.15 meter. So you have to take this and multiply by this, which is the radius of gyration k. The symbol that we use is lowercase letter k squared. You will be able to find out the second moment of mass or the moment of inertia. So the question asks us to determine or to find the coefficient of fluctuation of speed, that is the phi, when the engine runs at 1,800 revolutions per minute. Convert this to radians per second. So first thing is, this will be our turning moment diagram, T against theta. So anything above, sorry, I should shut down the animation here. Above, positive, below, negative, above, positive, below is negative, above, and below. So first thing is, we look at the scale that is given. The first one is 1 mm equivalent to 5 Newton meter. The other one is 1 mm equivalent to 1 degree. So if you take 1 mm times 1 mm, you will have the area of 1 millimeter square. So the area of 1 millimeter square will be equals to 5 times this angle here in radians. And that will give you this value here. 5.56 times 10 to the power of negative 3 is actually 1 over 180. So multiply by pi. We don't multiply the pi, we just let the pi be there, so that, okay, we can control the decimal places. So here, what we have is, let the energy at point A be Z mm squared. So the area, the energy in the flywheel at this point here, just let it be Z mm squared. So in terms of millimeter squared. And we know that this, at point B, this area here, this section here is above. So therefore, we have Z plus 295. So that is the first. Okay. So the next one is at point C. Okay. So I can't show this diagram here. So at point C, you have the area below. So you take plus 295 minus 685. So you will have negative 390. Okay. So for this negative 350, you have plus 295 minus 685 plus 40. So you have negative 350. And then at point E, you just go ahead with the calculation here. Plus 295 minus 685 plus 40 and minus 340. So you got negative 690. Then you have plus 295 minus 685 plus 40 minus 340 and plus 960. You should have Z plus 270. And then minus the last one, which is negative 270. You will get at point G, that means that is the last point, which is shown in the diagram. Okay, so you have z left over as squared. So from here, you have to choose, okay, with all these values here, which one would be the maximum? This would be the maximum. This would be the minimum. So from this, we will be able to find out the greatest fluctuation of energy, that is beta W. Before that, convert the mean speed, which is in RPM, revolutions per minute, into radians per second. So by now you should know, which is equals to 2 pi n over 60, where 2 pi, because of these revolutions here to radian is 2 pi, and then this minute to second, so it is divided by 60. So you've got 188.5 radians per second. So for the second moment of mass or the moment of inertia, we have I is equals to the product of mk squared, where m is the mass and k is the radius of gyration. So you have 36 kg and this is 0.15 meter. So you have the moment of inertia. So the question asks us to find the phi, that is the coefficient fluctuation of speed. Before that, the beta W, take maximum minus minimum energy, which is in squared. If you take this, multiply by this value here, you would have this all converted to Newton meter per millimeter square. Okay, so after that you can solve this, okay, later on. Okay, so you will have this as a result. Okay, with this, the z and the z here will cancel off. So you have minus and minus become plus. So add up both, you got 985. So from this, you will be able to find beta W is 86.03 Newton meter, which is also in joules. Okay, so based on the formula that we have derived earlier, the phi will be the coefficient fluctuation of speed. So this is our objective, to find the phi, or this will be the subject. So you have this, and then you can find out the phi. You round up this figure here, so you get 0.003 for the coefficient of fluctuation of speed. Now, this would be the first example. Okay, we will proceed with the next. And for the time being, thank you very much.